All right, hello everyone. Today we are going to learn how to interpret statements of inequality as statements about the relative position of two numbers on a number line diagram, and how to write, interpret, and explain statements of order for rational numbers in real-world context. Whoa, that sounds really confusing and complex, but don't worry, it is not as complex and confusing as it sounds. We're going to break it up and you will learn it really quickly. So a number line. You are all very familiar with number lines. You have been using them for many years now. All right, and so we have 0, and every number to the right of 0 is positive, and every number to the left of 0 is negative. You all know this. So let's just quickly go through and put these little sticky notes where they belong on the number line. So 3 belongs here, 5 belongs here, -4, -1. So each of these numbers, each of these values belong on a specific spot on the number line, right? If I move this -4 over here, that's not where it belongs. That is not representative of its value. -4 belongs here. It is 4, 1, 2, 3, 4 less than 0. It has a specific value there on the number line. So we can look at all of these different numbers, -4, -1, 3, 5, and any other number that you can think of, and compare them using inequalities. Remember, inequalities are greater than, less than symbols. You've also been using those for a while. So inequalities are just two numbers that are not equal, and we can compare them. So let's go through some examples of these numbers in yellow and how we would compare them with inequality. So the first one, you all know, right? 3 is less than 5. 3 is a smaller number than 5. We're all good? Next, this is where things are going to start to get new and maybe a little tricky. -4 is less than -1. -4 is less than -1. This is weird because when we're talking about positive numbers, 4 and 1, if they were both positive, 4 would be greater than 1. This is what can confuse us in our heads because we're so used to working with positive numbers. But with negative numbers, -4 is 4 less than 0. It is a small, small number compared to -1. It is a smaller number because it is farther left, more negative on the number line. Let's look at another one. Oh, this one is just the inverse of what we were just talking about. -1 is greater than -4. See, -1 is a bigger number. Even though it's negative, it's a bigger number than -4. -4 has a smaller value. -1 has a bigger value. It is more to the right than it is to the left. Let's look at another one. Okay, 3 is greater than -4. 3 is greater than -4. Right? This can confuse people too because we have 3 and 4. Normally we would say 4 is greater than 3, but no, not in this case. 3, positive 3, is greater value than -4. -4 is a smaller number than 3. And our last example, let's see what it is. Oh, nope, that was our last example. Okay, continuing on. Why do I need to know this? Why? Let's try to think of some real world examples. I'm going to give you a minute to pause and think of some real world examples of when you might be comparing positive and negative values in the real world using inequalities. All right, I hope you maybe thought of one. If not, we're going to go over 3, and hey, maybe the one you thought of is the same one that I thought of. Okay, So the first one I thought of was temperature, right? Temperature can be negative or positive. Not so much in Mobile, Alabama, but where I'm from in New England, it can get below zero. The temperature can be less than zero. It can be -5 degrees outside, right? So we can compare temperature. We can say -5 degrees is less than 0 degrees, for example. Another one, elevation, right? That's our distance from sea level, right? Sea level is zero in geography or topography, I think. Um, elevation is zero, and anything or elevation, sea level is zero, and anything above zero is higher up, right? We're above sea level. And then in some places like New Orleans, it's actually below sea level. So the elevation would actually be a negative number. And the last example came up with was money, right? You can have less than $0. It's not good to have less than $0, but it happens, and that's called debt, right? If you owe somebody money, you're negative money. You have negative dollars. It's weird, but it happens. It happens a lot. All right, so let's look at some example problems now. Kaylin looks at her thermometer and it reads -4 degrees Celsius. Yesterday it was -9. Write an inequality that represents the relationship between those two temperatures. All right, so let's just plot these two values on our number line. So -9 is down here and -4 is right here. Okay, so -9 and -4. We have these two values, and this is on a thermometer, so she's comparing temperature. So let's write an inequality that represents the relationship between these two problems. So we need to think, is -9 less than or greater than -4? Think about that for a moment. Is -9 less than or greater than -4? If you said less than, ding, 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 you are correct. -9 is less than -4 because it is more negative. That's how I think of it. It's more negative. It is farther from zero. It is 9 spaces down from zero, 9 to the left from zero, where -4 is only 4 to the left of zero. So -4 degrees is actually warmer than -9 degrees. That's another way to think of it if we're talking about temperature. Is -4 or negative whatever number it is that warmer or colder? That's how we can compare it and know greater than or less than. Next example. Okay, Sarah is given the inequality -37 is less than -11. What could this inequality represent? So now we're connecting it back to the real world. Let's do some sticky notes of these real world examples. Do you remember any of them? Well, our last problem talked about temperature. Ooh, I did not spell that right. Spell check. Temperature. So temperature, right? It could be -37 degrees Fahrenheit. That would be freezing cold, but that would be colder or less than -11. We could also have money. We could be talking about money, right? Sarah could owe her friend $37, while Sarah's brother could owe the friend $11. Sarah would be more in debt than her brother. And the last example, let's see if we can think of it. Temperature, money, and elevation. That is our last example. So that's how high up or below sea level you are. Sea level is 0. So if you're on top of a mountain, you may be 2,000 feet above sea level. But if you go down to New Orleans, you might be 45 feet below sea level, or -45 elevation versus positive 2,000 elevation. So these are some of our real world examples. symbols. All right, here we have two people, Braxton and Jabron. Braxton believes negative 14 is greater than negative 2. Jabron believes negative 14 is less than negative 2. Who is correct and why? Think about that for a second. All right, let's try to analyze and kind of put ourselves in like Braxton's shoes first. Okay, so Braxton believes negative 14 is greater than negative 2. I think Braxton is probably thinking 14 and 2. Well, 14 is a bigger number than 2. So that's why he said negative 14 is greater than negative 2. Okay, that's his thinking. But is that thinking correct? Unfortunately, it's not. It's not correct, right? Because negative 14 is farther down the number line. Let's make our number line real quick. Negative 14 would be somewhere like here. We just have a very open number line here. And negative 2 would be up here, right? Negative 2 is farther to the right. It's a higher value number than negative 14. Negative 14 is smaller. It's less than negative 2. So Jabron believes negative 14 is less than negative 2. And he is correct. Jabron has the correct thinking, right? So this can be tricky because we tend to just look at the numbers 14 and 2, and we forget about the negative or positive symbols. And negative and positives are very, very important, and they are going to continue to be more and more important as you go farther and farther along on your math journey and gain more and more math knowledge. We cannot forget about them. They are very important, and they describe the value of numbers. And we can compare those numbers using inequalities. I hope you learned a lot through this video, and if you have any questions, let me know. Goodbye.